In the world of high-performance cars, few names carry as much weight as Bugatti. Known for building some of the fastest and most expensive cars ever made, Bugatti has always stood for extreme engineering, precision, and exclusivity. One of its most famous creations, the Bugatti Chiron, is often described as a masterpiece of modern automotive design. It is not just a car. It is a complex machine built with advanced materials like carbon fiber, powered by a massive W16 engine, and designed to push the limits of speed and performance. Because of this complexity, Bugatti has always maintained that only a very small number of people in the world have the skill and tools required to repair or take apart such a vehicle. According to the company, certain procedures, like separating the front and rear sections of the Chiron, can only be done in a few specialized facilities with factory-trained technicians. This belief has been widely accepted in the automotive world for years. However, this idea was recently challenged by a well-known automotive YouTuber and car rebuilder, Mat Armstrong. Known for taking damaged or written-off cars and bringing them back to life, Mat decided to attempt something that many believed was impossible outside of Bugatti's official network. His goal was simple but bold: to rebuild a crashed Chiron and prove that even a car as complex as this could be worked on in a normal garage. This challenge quickly became more than just a rebuild project. It turned into a test of whether the automotive world had been overestimating the difficulty of such machines, or whether Bugatti's claims were truly justified. As the project gained attention, it sparked debate among car enthusiasts, engineers, and viewers around the world. Could an independent garage really achieve something that the manufacturer claimed required special facilities? Or would the attempt prove just how difficult these hypercars really are to work on? This article explores that journey in detail, breaking down what happened, how the process unfolded, and what it means for the future of car repair and ownership. To understand the importance of Mat Armstrong's attempt, it is necessary to first look at Bugatti's official position on the matter. The company has always emphasized that the Chiron is not like a normal car. It is built using highly specialized methods, and many of its parts are designed to work together in very precise ways. According to statements made by Mat Armstrong, the process of separating the Chiron's front and rear sections is extremely complicated. The car is built around a carbon fiber monocoque, which acts as the main structure, and the rear section includes the engine, transmission, and other critical components. These two sections are connected by multiple systems, including electrical wiring, fuel lines, coolant pipes, and hydraulic connections. Rimac explained that because of the complexity of these systems, taking a car apart requires not only special tools, but also deep knowledge and training. He stated that only a few facilities in the world are equipped to handle such work, and even fewer technicians have the experience needed to do it safely. This message created a strong belief that attempting such a task outside of these facilities would be risky and likely unsuccessful. It also raised concerns about safety, as any mistake could damage the car or make it unsafe to use. For many people, this explanation made sense. After all, a car that costs millions of dollars and reaches incredible speeds must have a level of complexity that goes beyond ordinary vehicles. However, others began to question whether this exclusivity was entirely necessary. Was it really impossible for skilled mechanics outside the official network to work on such a car, or was it simply a way for the manufacturer to maintain control over repairs and servicing? This question became the driving force behind Mat Armstrong's project. By attempting to separate the Chiron in his own workshop, he aimed to test these claims in a real-world situation. His approach was not backed by factory manuals or official guidance. Instead, it relied on observation, logic, and hands-on experience. This made the challenge even more interesting, as it removed the advantage of having inside knowledge and forced the team to figure everything out step by step. When Mat Armstrong began working on the Chiron, the first step was to carefully study the car and plan how to approach the disassembly. Without access to official documentation, the team had to rely on what they could see and understand from the car itself. This meant starting with the outer body panels and slowly working inward. The process began with removing parts like side skirts, trim pieces, and panels that were held in place by bolts, clips, and adhesive materials. As each piece was removed, more hidden fasteners were revealed underneath. This is a common design approach in many modern cars, where parts are layered to improve strength and appearance. What made the Chiron different was the scale and precision of these components. Many of the parts were made from carbon fiber, which is both strong and lightweight, but also expensive and delicate to handle. Despite this, the team found that the process of removing these parts was not as mysterious as it had been made to seem. It required patience and attention to detail, but it did not involve any special tools that were not already available in a well-equipped garage. As they continued, they removed larger sections of the car, including the rear quarter panels. These panels, which might appear to be permanently attached, were actually bolted in place and could be removed as single units. This revealed more of the car's internal structure and provided a clearer view of how the front and rear sections were connected. Throughout this process, Matt was joined by his father, Tony, whose confidence and experience played an important role. Their teamwork showed that even complex tasks can become manageable when approached with the right mindset. Each step built on the previous one, gradually turning what seemed like an impossible challenge into a series of smaller, achievable tasks. As more of the Chiron was taken apart, the team began to see how the car was truly constructed. One of the most important discoveries was the way the front monocoque and rear subframe were connected. According to Bugatti's own information, these sections are held together by a set of titanium bolts. In total, there are 14 of these bolts, and they play a crucial role in maintaining the strength and integrity of the car. At first, only some of these bolts were visible, while others were hidden behind components like airboxes and structural elements. To access them, the team had to remove additional parts, which again required careful work, but no unusual tools. Once these components were out of the way, all 14 bolts could be identified. This was a key moment in the process, as it showed that the connection between the two main sections of the car was not as inaccessible as previously believed. The bolts themselves were high quality and precisely engineered, reflecting the overall design philosophy of the car. However, they were still standard fasteners that could be removed using the correct tools. Alongside the bolts, the team also had to deal with the various systems connecting the front and rear of the car. This included electrical wiring, fluid lines, and other connections that needed to be carefully disconnected before separation could occur. While this might sound complicated, the layout of these systems was found to be logical and organized. Each connection had a clear purpose, and by following the layout step by step, the team was able to manage the process without confusion. This stage of the project highlighted an important point. Complexity does not always mean impossibility. Even though the Chiron is a highly advanced machine, its design still follows basic engineering principles that can be understood with careful observation. The most critical moment in the entire project came when it was time to actually separate the front and rear sections of the Chiron. This was the step that Bugatti had described as requiring special facilities and trained technicians. After removing all the necessary bolts and disconnecting the systems linking the two sections, the team prepared for the separation. This required careful positioning and support to ensure that both halves of the car remained stable during the process. As they began, the movement was slow and controlled. There was no sudden resistance or unexpected difficulty. Instead, the two sections started to come apart in a smooth and predictable way. This was a surprising result, especially given the earlier claims about the difficulty of the task. It showed that once the correct steps were followed, the process could be carried out safely even outside of a factory environment. The separation revealed the engine and transmission in full view, allowing for further inspection and repair work. It also provided a clear demonstration of how the car was designed to be assembled and disassembled. This moment was not just a technical achievement. It was also a symbolic one. It challenged the idea that certain tasks are beyond the reach of independent mechanics. At the same time, it did not mean that the process was easy or that anyone could do it without experience. It still required skill, patience, and careful planning. However, it showed that the barriers were not as absolute as they had been presented. For viewers and enthusiasts, this was one of the most exciting parts of the project, as it provided a clear answer to the question that had been raised from the beginning. The successful separation of the Bugatti Chiron by Mat Armstrong and his team has important implications for the automotive world. First, it shows that independent garages, when equipped with the right tools and knowledge, can take on challenges that were once thought to be limited to manufacturers. This could encourage more people to attempt complex repairs and restorations, leading to greater innovation and creativity in the field. Second, It raises questions about the way manufacturers control access to information and parts. While it is understandable that companies want to protect their products and ensure safety, there's also a growing demand for greater transparency and accessibility. Projects like this highlight the value of open knowledge and the potential benefits of allowing skilled individuals to work on advanced machines. At the same time, it is important to recognize that not every garage will have the ability to carry out such work. The Chiron is still a highly specialized vehicle, and mistakes can be costly. Therefore, this achievement should be seen as an example of what is possible rather than a standard expectation. Finally, the project demonstrates the power of determination and curiosity. By questioning accepted ideas and testing them in practice, Mat Armstrong was able to achieve something remarkable. His work has inspired many viewers and has contributed to a broader discussion about the future of car repair and ownership. As technology continues to advance, these discussions will become even more important. The story of this rebuild is not just about one car. It is about the relationship between manufacturers, mechanics, and enthusiasts, and how that relationship may change in the years to come. As the rebuild continued after the successful separation, a deeper understanding of the engineering behind the Bugatti Chiron began to emerge. What initially appeared to be an extremely complex and almost mysterious machine slowly revealed itself to be something more logical and structured. Every part of the car seemed to follow a clear purpose, and each system was arranged in a way that made sense when viewed step by step. The use of carbon fiber was one of the most striking features. This material is known for being both very strong and very light, which is why it is often used in high-performance cars. In the Chiron, large sections of the body, including structural parts, are made from carbon fiber. This not only helps reduce weight, but also increases strength and safety. As Matt and his team removed different components, they noticed how precisely everything was built. The bolts, brackets, and panels were all designed to fit together perfectly, almost like pieces of a puzzle. This level of precision is part of what makes the car so special, but also shows that the design is not random or overly complicated without reason. Instead, it is carefully planned to achieve the best possible performance. Another important observation was how the systems were organized. The wiring, for example, was not tangled or confusing. It was routed in clear paths, often grouped together and secured in place. The same was true for fluid lines, such as those carrying coolant or fuel. These were positioned in a way that allowed them to be accessed and disconnected when needed. This organization made the disassembly process smoother and reduced the risk of mistakes. It also suggested that the car was designed with maintenance in mind, even if that maintenance was expected to be done by trained professionals. Overall, this stage of the project showed that while the Chiron is indeed a highly advanced machine, it is still built on understandable engineering principles. By taking the time to carefully study and follow these principles, the team was able to work through the car in a methodical and effective way. Despite the progress and success in separating the car, the rebuild was far from easy. Mat Armstrong and his team faced several challenges along the way, which highlighted the difficulty of working on a hypercar like the Bugatti Chiron. One of the biggest challenges was a lack of official information. Without access to factory manuals or detailed instructions, the team had to rely entirely on their own understanding and experience. This meant that every step had to be approached with caution. A wrong move could damage expensive components or create new problems that would be difficult to fix. Another challenge was the cost and rarity of the parts involved. Many of the components in the Chiron are not only expensive but also hard to find. If something were to break or be damaged during the process, replacing it could take a long time and cost a significant amount of money. This added pressure to every decision the team made. They had to balance speed with care, making sure that they did not rush through any step. Handling carbon fiber parts was another area that required special attention. While carbon fiber is strong, it can also be brittle under certain conditions. This means that it can crack or break if not handled properly. The team had to be very careful when removing and moving these parts to avoid causing damage. In addition to these technical challenges, there was also the mental pressure of the project. Knowing that they were attempting something that many believed was impossible added extra stress. There was always a possibility that something could go wrong, which would not only affect the car, but also their reputation. However, instead of letting this pressure stop them, The team used it as motivation. They stayed focused, worked together, and continued to move forward step by step. This ability to manage both technical and mental challenges played a key role in their success. As the project unfolded, it quickly gained attention online, especially on platforms like YouTube, where Mat Armstrong shares his work. Viewers from around the world followed the rebuild closely, watching each step and reacting to progress. The idea of taking apart a Bugatti Chiron in a regular garage was exciting and unexpected, which helped the videos gain a large audience. Many viewers were impressed by the skill and determination shown by the team. They appreciated the clear and detailed way the process was presented, which made it easier to understand what was happening. For car enthusiasts, this was a rare opportunity to see the inner workings of a hypercar, something that is usually hidden from public view. At the same time, the project also sparked debate. Some people supported Matt's approach and saw it as proof that independent mechanics are capable of more than they are often given credit for. Others were more cautious, pointing out the risks involved and the importance of proper training and equipment. This mix of opinions created a lively discussion, which further increased interest in the project. The videos also helped educate viewers about the complexity of modern cars and the skills required to work on them. By showing both the successes and challenges,